Alright, welcome back everyone. This will be a slightly different video from usual. I think it would be good to see how a mini quiz can match up and see if you're ready for your first test. I thought a lot about how to do this, and the conclusion I came up with is dedicating the first bit to sort of scrolling through the questions, and the second bit to actually solving said questions. This would mean the video is going to be slightly long as I'll explain every problem, but remember you can skip and pause whenever convenient. Anyways, these problems I've selected give a pretty holistic coverage, so you should see the rough distribution on your test as well. Now, if you can solve these problems within their time limits, I'm sure you can get above a 90% on your first test. Without further ado, let's go through the questions. This is the first question. It tests classification of matter. As you can see, you have 6 minutes to solve it, and if you get it wrong, you should go watch video number 1 of this chapter, Understanding Matter Part 1. Second question, 2 minutes to solve, and you want to review the same video, Understanding Matter Part 1. Question number 3, multiple choice, 2 minutes. This one is video number 2, Understanding Matter Part 2. Question number 4 is a fill in the blank, 5 minutes, and this is Understanding Matter Part 1 again. Question number 5, 8 minutes. This is Understanding Matter Part 2. Question number 6, 5 minutes, Understanding Matter Part 2. Question number 7, 2 minutes, sig figs. Question number 8, 5 minutes, sig figs. And question number 9, 7 minutes, dimensional analysis. Alright, so those are the problems. Let's get into how we can solve said problems. Problem number 1 is a classification of matter problem, trail mix. So, this is the example I used in my first video, and we know it's clearly heterogeneous, as we can separate the nuts quite easily. We know it's not uniform, and it's definitely a mixture, hence, heterogeneous mixture. The second one is tungsten. This is W on the periodic table, which is an element, and that just makes it an element. Bronze, copper, and tin are not chemically bonded in this, so we cannot call this a pure compound. It's not, it's a homogeneous mixture. Simple syrup, also homogeneous mixture, similar concept to tea. Uniform, but we can separate it through evaporation. White vinegar is also a homogeneous mixture, can be separated, and it is also uniform, so therefore homogeneous mixture. Squirrels, this one's a bit of a wacky one, but this one's a heterogeneous mixture. This is one of the different phases exception to heterogeneous mixtures, and we clearly know that makes it heterogeneous. Silicon, this is also an element. We see it on the periodic table, Si. Compressed air, homogeneous, different molecules, looks all the same, and not chemically bonded. As you can see, there weren't any problem with compounds. These are usually pretty rare. We won't see them that much. We'll usually see them with more visuals. Depend that the compounds are chemically bonded, and we haven't learned chemically bonds yet, so you won't see that much of it. So this question is basically asking, based on the molecular structure, explain why gas and liquids are fluids while solids are not. This requires a bit of understanding. We discussed how solids are rigid and have a solid structure, while liquids and gases had a free-flowing structure allowing them to take the shape of the container. You want this to phrase your answer. So in this case, I would write something along the lines that solids have a rigid structure. This prevents molecules from flowing and moving easily, while on the other hand, liquids and gases take the shape of the container, and as such, molecules can flow past each other much more easily. This allows gases and liquids to be fluids. That should give you a pretty in-depth answer, and the professor will like one of these answers. Now, number 3. This one's talking about chemical properties. The only answer here is C, because that's the only one that changes the identity of the chemical. We're talking about how hydrogen gas can become water, and that's a chemical identity change. A, C, and D talk about physical changes, which, once again, are not chemical changes. Now, number 4 is simply a memorization question. There's not much thinking here. Solid to liquid's freezing, liquid to solid is melting, liquid to gas is evaporation, gas to liquid is condensation, solid to gas is sublimation, and gas to solid is deposition. Pretty simple there. Make sure you memorize these. It's going to be somewhere on the test. 5 is a little bit more critical thinking. Let's start with intensive versus extensive. With color going first, we know this one's intensive. This was used as an example. The amount does not correlate with the color of the object, and hence it's not dependent on amount, and therefore color is an intensive property. Now for combustibility, this is also intensive. More if the object doesn't make it any more likely to combust, it just increases the danger. That's a different property, so therefore combustibility is also intensive. Hardness is also intensive. More diamonds doesn't increase the hardness of each diamond. Mass is also extensive. This one's a little bit different. More bricks means a more heavier overall mass. Melting point is intensive. Once again, more ice does not change the melting point of said ice. It's still going to be 0 degrees Celsius. Ductility, this one is the amount something can distort. This is intensive, more material does not change that figure. Volume is extensive. After all, more bricks means more volume. Reactivity with acid is intensive. This will make the amounts will not correlate to whether something reacts more or less. Odor is a bit tricky, but this one is also intensive. The odor, which is the smell of something, doesn't change by having more of something, it just gets stronger. That's a different property. And weight, that's extensive. Once again, more bricks, more heavy. Malleability is intensive. Same with ductility. More material does not change that figure. And now let's go back and check the chemical and physical properties. Color is a physical. It's the same chemical identity, combustibility, chemical, because it will change upon its identity upon combustion. Hardness is physical, same chemical identity. Mass is extensive, but it's also like physical since it has the same chemical identity. Melting point is physical. Remember, phase changes don't affect identity. Ductility, physical, same chemical identity. Volume, physical, same chemical identity. Reactivity with acid is chemical because it'll change identity upon reacting with acid. Odor, physical, same chemical identity. Weight, physical, same chemical identity. And malleability, physical, same chemical identity. Now let's assign these qualities to the descriptions. The first one is volume, cm cubed. Flattened with sheets is malleability. You sort of have to know this one. Grams over centimeters to the power of -3 is density. Burns in O2 is combustibility. Scratched by diamond is hardness. Drawn into a wire is ductility. NaCl melting is melting point. Grams is mass. Now moving on, why does a conversion factor have infinite sig figs? Because it's a defined number. However, between kilograms and pounds, it's not the same system, so you need sig figs. Now, measurement value, this one usually sucks a bit. The first one is, if we count 12 spaces, it would be pico, so 77 pm. Second one is 7 decimal places, so 85 um. Third one is 4 decimal places, so we can go with 1.86 centigrams and keep this one's unit. 9 is nano, so 4, so 5.89 nanoseconds. 5 is in the millions, so 6.12 mega inches. 6 is in the thousands, so 4.216 kilograms. Final question, we have 1 Olympic mile is 1,500 meters, US mile is 5,280 feet, and there is 3.28 feet in a meter. We're finding the percent mile in an Olympic is to a US one. The simple way to do this is to get everything into US miles. So 1 Olympic mile multiplied by 1,500 meters over 1 Olympic mile multiplied by 3.28 feet over 1 meter multiplied by 1 mile over 5,280 feet. This should get us 0.9318, and when that's converted into percentage, we get 93.18%. Anyways, that is all. Hopefully you could solve this 100 correctly, and if so, you're probably ready for your next test. If not, please rewatch the corresponding videos and hopefully you get it right this time. Anyways, that is all, and happy studying. Take care. Bye.